Hi, Cal Rides here. When you're trusting your whole online life to a single company, you have to make sure you can trust them and the software they've made. Here's a few videos from the TWIT show Security Now with Steve Gibson, the man who coined the term spyware and created the first anti-spyware software. In these videos, he explains how LastPass security works. This video is part of a blog post I produced for giffgaff on securing your digital life with LastPass and YubiKey. I'll leave the link to the blog post in the video description below. In the meantime, here's the videos from TWIT.
This is Security Now with Steve Gibson, episode 256, recorded July 9th, 2010. LastPass Security. Now, LastPass. I think I found out about LastPass from this show. I think somebody wrote a note. I've used RoboForm, which was Windows only. I think they're doing a Mac client. Then I've also on the Mac used 1Password, which was Windows, rather Mac only. But then when I found LastPass, first of all, it's very affordable. There's a good free version, and $1 a month you get some additional features. $1 a month, and it works on everything that I use, including all of my portable devices: the iPad, the iPhone, the Android systems, Blackberries. So I fell in love with this, but I'm not you, Steve. And I just trust it. I had to say, well, I trust that they're doing it right. It looks like they're doing it right. But I'm very glad that we're going to get this. We're going to find out. The Steve Gibson checkout.
Okay. So one thing I want to do in this podcast is I'm going to go against something that we've done in the past, which is to rely heavily upon previous podcasts.
Okay.
For explaining the crypto stuff, I'm not going to assume any prior knowledge. We're not going to go into the depth that we have before. So people who want to follow up, who will say, well, I want to actually understand how some of these things that Steve talked about actually work. We've covered all of this in the past. So that's all there. But I don't want to assume that someone listening to this remembers all of that. So on the crypto stuff, there'll be a little bit of redundancy that way, but not a painful amount of it. Because the reason I say this is understanding the architecture that these guys developed is the key to understanding why it's safe to trust them, why I trust them, and why I've completely switched my entire solution for managing passwords after spending days researching it and testing it and playing with it over to LastPass, which I have. So let's step back a little bit and look at and understand what the problem is we're trying to solve. The very early episodes of this podcast, nearly 5 years ago, we spent several episodes talking about passwords, personal password policies, and the whole issue. And the password is the sort of the original security technology. I mean, backdating from the early days of Unix machines, which were the first machines on networks, it became important, became crucial, necessary to identify users. And so the idea was you'd have a username and you'd have a password. The idea being that the username was something everyone knew, it was public, but the password was something only you knew. And we've talked about the whole problem of managing passwords. The problem is that all other things being secure, that is, assuming that a system of some sort, whatever it is, doesn't have any other security problems. If it's password-based, then the one vulnerability is guessing the password. That is, if you know someone's username, you can think, okay, and we've seen this in movies and things. It's like, okay, let's see, what might their password be? Well, I know the name of their kids. Let's try that. I know the name of the dog and their parents and the
dog
city
is
they
what
live.
happened to Paris Hilton. Everybody knew her dog's name.
Right. Not a good password
to
use for that reason. So the problem is that the vulnerability is guessing the password. In fact, remember that just last week we talked about the FBI and the Brazilian government both failing after years of trying to crack the TrueCrypt encryption of someone whose drives they had acquired, who was a suspected money launderer. They spent years using a dictionary attack where they had a dictionary of words that they just kept trying. Well, that was brute force password guessing. That this person whose drives these was smart enough to use a password not in the dictionary. Had it been a simple dictionary-based word, his security would have been cracked that way. So the idea is you want a password that isn't going to be guessable, that isn't in the dictionary. Well, the other thing you need is something, if it's so we'll call it gibberish. You know, it's 32x5707 or something, just gibberish. Now the problem is it needs to be long, because the next attack on a gibberish password is to try every possible combination of gibberish. You know, you start with A, then you don't use A. That's a bad password, by the way. That's the first one you. That's the other first one you
or
try.
Z, because sometimes they try the backwards way.
Yeah. Well, and even if you did Z, but they started at A, that's only going to take them 26
That's
tries.
a good point. Yeah. So anything A through Z, bad.
Bad. Yeah. And then you go A, B, A, C, A, D, and so on. And so now if it's a 2-character password, and if assuming it was all, for example, lowercase, well, then it's going to be 26 squared, and we can still try that many in a short time. So the point is that it is possible in many scenarios to try every possible password. Now, every possible password gets to be many pretty quickly. But what that means is the longer your password is, the stronger it is, because every character you add, say that we have the characters lowercase a through z, that gives us 26 possible characters in the so-called alphabet. Then say we had then uppercase a through z, and that these passwords are case sensitive, meaning that it matters whether it's an uppercase a or lowercase a. So before we had 26 lowercase, now we add 26 uppercase, so we're to 52. Now if we add the digits 0 through 9, we're at 62. And say that we just add 2 more special characters, plus and minus. That is, we allow a plus symbol or a minus symbol. Well, that gets us to 64. Well, 64 is a special number because that's 2 to the power of 6, which is to say it's the same as 6 bits of password strength. So using just the alphabet and the digits, plus a couple more characters, we get 6 bits of strength per character, which is to say 64 possible combinations for a single character. For 2 characters, that's 64 times 64, because we have all of the possible characters with 64, and then 64 of those first characters for all the second characters. And if we add 3 characters, it's 64 times more, and the 4th character 64 times more. Well, if you start multiplying 64s, this gets to be a very big number very quickly. So the point is that computers are fast, and who knows whether the FBI actually started trying gibberish. Maybe they did. But if it was sufficiently long gibberish, you just can't try them all.
Well, how many years did they try it?
Well, they tried for many years. I think it was 2 years.
2 years, if they have fast systems, is a billions and billions of attempts.
Attempts, yes. Although systems are also, and I think TrueCrypt being a well-designed system, the other thing that systems will do, and I know, for example, that WPA, the good encryption for Wi-Fi, does this, is that the actual algorithm for turning a password into a key is itself complicated. So I don't remember, I think it's 4,096 iterations of some cryptographic functions that WPA goes through. So a single attempt takes a while, but not long. It's short enough that we don't notice it. But what it means is that many attempts is scaled up by a deliberate increase in the complexity of the algorithm that gets the key from the password. And I would be surprised if TrueCrypt hadn't done the same thing. So that meant it was infeasible. That is to say, yes, you can try lots of passwords, but each one is expensive in computational.
It's gonna take you a while. Yeah.
Exactly,
yeah.
in computational time. And that's a deliberate overhead added in, by good security people who want to prevent this kind of brute force, just try every possible combination of gibberish. So what we've done is in here in the last 10 minutes, we've walked through the problem. The problem is we want a really long gibberish password if we don't want, in order for it to be secure. Now, the next problem is, you could imagine, okay, I'm going to come up with a really long gibberish password. That's going to be my password. But you don't want to use the same one all the time, because the other problem is that, say you log on to your bank with your email address and this monster amazing password. It's like, great, that's safe. But if you also log on to, storiesmydogtoldme.com or something with
that's the problem.
with your email address and the same same monster amazing password.
Exactly.
Now the problem is, yes, that's really strong, except that we're not too sure about the security of the website storiesmydogtoldme.com, nor about the employees who work there. Because remember, they got your email address and this amazing monster incredible password of yours. So, and the same as might be the case with malware in your computer. We know that people are getting themselves infected. If malware saw you log on to storiesmydogtoldme.com with your email address and this monster incredible password, there's nothing to prevent it from rummaging around in your computer and noticing that you're a B of A customer and thinking, I wonder if this person uses the same monster incredible password for all of the different sites they visit. And so you can imagine, if you were someone who had an amazing password, but you only used one,
right?
Then think of the liability. Everyone and all the sites you log into, whether it's Facebook or Twitter or Tweet Me or Stories My Dog Told Me, and your banks and everything, they've got your email address and your password, which means it's really not yours anymore.
No.
I mean, everybody has it. And if there's ever a chance, I mean, they could just guess, I wonder if this person uses B of A. I wonder if they use Chase. I wonder if they use, that they could just put in your email address and this password, and wow, it's going to work. If they guess even like where you might go, like what groups you're members of. So it is, not only do you need a really long, incredibly gibberishy password, but you need a bunch of them. So now we've got a big problem, because how do you handle that? How do you manage that? How do you, now you literally somehow have to write them all down or record them all, and this is a big problem. If it was sufficient to have one really monster incredible password, then it's like, okay, you could potentially memorize that. We've talked about fun ways to do that, like think of the lyrics of a favorite song and choose, the first character of each word in the lyrics in order to help you remember it. but then, maybe salt it with a few digits in between, or if the lyrics have the word for, use the number for, and then, that kind of stuff. So there are fun ways to help you with that. But the problem is that's not what you want to do, because we already established that it's really not safe to use the same or even a small set of really good passwords among a huge number of sites, because of this problems of inter-site or cross-site usage. So the way to be secure is to have long gibberishy passwords and a separate one for every place you log in. That way, no one can ever try to log you in, as you, to impersonate you for whatever nefarious purpose, if they know your password for this site doesn't help them at all on some other site, which is really what you want. The problem is managing that, which is what various password management tools do. LastPass does that. The idea is that that LastPass has plugins for that is additional functionality that they add to all of the popular browsers. They've got browser plugins from everything from IE version 6 on up, Firefox version 2 on all platforms that Firefox runs on, Google's Chrome from version 4 on all platforms where Chrome runs, Safari from version 3 on OS X and from version 5 on the PC, and even Opera, which is plug-in hostile. Opera doesn't have a plug-in architecture, so they use something called bookmarklets, which we'll talk about a little bit, because that's one of the solutions, for example, over on a browser like the iPad, where it also doesn't allow plugins. They actually have a clever solution. They have their own tabbed browser, which is, LastPass has now an iPad tabbed browser, which includes the LastPass functionality as a way to get it. Because here's one of the reasons I like LastPass so much is they've just completely covered the landscape. For mobile devices, they've got iPhone, iPod Touch, Apple's iOS. They have the tab browser for the iPad. They've got their plug-in for Android and for the RIM BlackBerry, for Windows Mobile, for Symbian, and for Palm's WebOS most recently. So it's everywhere. And that's really what you need, because essentially what we're going to do, what the security-conscious LastPass user will do is go through and probably improve your passwords. Probably there's been some laziness along the way. There's been the reuse of passwords that you like or that you've memorized just because, some new site that you're visiting for the first time says, what password do you want to use? And so you go, I think I'm going to use the one that I like. Well, okay, that's a danger, as we've established. So you really need to come up with and to even fix retroactively passwords which you're using which are not safe. The problem is, how do you remember them? And that's what LastPass solves. However, if it wasn't available on anything you might possibly want to log in on, now you've got another problem, because you've got these long gibberishy passwords that you can't possibly memorize, which is part of why they're so good. But unless they're available on any platform you would be using, you've got a problem. So they've got the bases covered, absolutely and completely.
Yeah, I use everything there could be used under the sun, and I haven't found anything that it doesn't work with.
No, it's always there.
Even the iPad.
Yes, even the iPad. What these bookmarklets are, a bookmarklet is a bit of JavaScript, which is like a URL that is, it sort of runs like script on a page. And that allows them to sort of shoehorn themselves in to literally any browser. So if you didn't have any plugin, or for example, you were using somebody else's browser that didn't have a plugin, you could still use these bookmarklets in order to get access to your own personal library of passwords. So that's what LastPass creates, is your own personal library of passwords. What LastPass users have, or a level of reasonable discomfort with, and I did when I was first installing this and setting things up. LastPass, has also a form fill-in capability, and it was suggesting, why don't you give me your credit card numbers? It's like, what? And it even has a secure vault where you can put just your own notes, which you want to have available anywhere that is on any of these platforms, containing anything whatsoever. The question is, how is this safe? How is it that I am not giving the LastPass people, who I want to trust, but do we trust everyone who works there? Do we trust everyone who has ever worked there in the past, who will ever work there in the future? Do we trust, that somebody won't break into their servers and in the middle of the night and, have this huge, massive win of getting all of the username and passwords for everyone who is using LastPass? So the way this works is, and the reason I'm using it is I now understand how it works, and why it's absolutely trustable is that, very much like Jungle Disk, which we've talked about in the past, all the encryption is done locally. That is, at no point does LastPass receive anything other than what looks like a block of pseudo-random noise. We've talked about how when you take so-called plain text, the normal readable, human readable, your username as an email address and your actual password, and you encrypt it with a good cipher, it turns it into, under the influence of a key, which is the key to the whole process, under the influence of the key, it turns it into noise. Absolute pseudo-random bits that mean nothing. So that's what the LastPass system gets and saves. It is absolutely no use to anyone because they never get the key, and they've gone to great lengths to arrange never to get the key. When you log into their system, you do so with your username, which is your email address, and your password. That's put together, concatenated into one long string. They sanitize the username a little bit. They lowercase it, and they remove the so-called white space, spaces and things. That just makes it a little more robust. The password, they don't change at all. So that remains case sensitive, and special characters and things can be in there. They leave that alone. But for example, email addresses are not case sensitive. You can change the case in an email address. And so since they're using their email address, people's email addresses as their password, users might not be careful about the case in their email addresses. So they make that case insensitive. They always lowercase the email address ASCII characters, the alphabetic characters. So they put all this together into one blob. Then they do something called a hash. They use SHA 256, which is SHA stands for Secure Hashing Algorithm. The listeners that have been listening to the podcast for years know what that means. For people new to this, a hash is what's called a one-way function. You can take any amount of text or anything, binary data, anything, any amount of data, and run it through this process called hashing, which always results in a fixed size thing, sort of a fixed size token. And what's unique about this is it is computationally infeasible, is the technical jargon that cryptographers use, to go the other direction. That is, it's very easy to put stuff into this, think of it like sort of as a meat grinder, but it's impossible to ungrind the meat. It's been ground up. It's been turned into this 256-bit result, such that anything you change in the input changes everything about the bits in the output. Yet anybody, no matter how much they want to, no matter how much they look at it, they can't go the other direction. So the idea is that when you log in, when you give your system your LastPass username and password, the first thing it does is it runs it through this SSH, it lowercases the email address, removes the white space, adds the password, and then it does this hash to it, turning it into a 256-bit blob, which tells the blob holder nothing about your username and password. It's like it's been digested into this thing. In fact, hashes are called digests also for that reason. What that is your cryptographic key. That's the key which your system will use both to encrypt your data, which is being shared with LastPass corporate, and also to decrypt it when LastPass corporate sends this back to you. They're holding the encrypted results of your own personal database just because that's what they do. That's the service they provide, essentially, that and creating all these amazing plugins for everything anyone's ever heard of. So, but what they're holding, they have no ability to decrypt. They never get the key. That never leaves your system. Now, they do need to know that it's you. That is, they need to know that it is you who are logging in, so that so that there needs to be an authentication process so you identify yourself to them. But we don't want them to get the key. So what they do is they take that key, the cryptographic key, and they add your password to it. That is, they concatenate your password to your cryptographic key, and they hash that. So they do another one-way function on your crypto key with your password, which they don't know because they never get it, but they get another blob. So this second blob, the second output from the hash, that's your unique ID. That is, the only way to get that is if you take your username and password, hash it, then add the password to that and hash it again. So it absolutely depends upon both of those pieces of information. So then your username and that goes to LastPass to identify you. And because that contains your password twice hashed into it, nobody who doesn't have your password, even if they have your email address, is able to produce that blob. So you have to have your email address and your password run through this hash twice to get that blob. But notice that your cryptographic key, which is sort of the first byproduct of that, because that's the output from the first hash, that goes into the second hash but is lost in the hashing process. So thanks to it being mixed with your password. So the LastPass people never get your crypto key. They get a different unique token that identifies you to them so that you're able to log on securely to their facility. And these guys are so paranoid that they don't even save that on their servers. They don't even save that special logon blob, the output from that second hashing process. Instead, at the time you create your account, they they use a random number generator at their headquarters to create a unique 256-bit token, which they save with your account. And whenever you're logging in, they take this 256 blob you're sending them, that's the result of these two hashing processes, they add that to this unique 256K random number, and they hash that, and that's what they compare to what's stored with your account. So, which is to say, they never store that logon token. They store the result of hashing that logon token with a unique 256-bit value that they created for you, so they dynamically see if it's the same, but they never save your logon token. They don't want it. They don't need it, so they're able to perform a dynamic check whenever you need to authenticate, but they don't keep it statically. So, I mean, this thing is secure every way you can imagine, and it's simple. The reason it appeals to me is that there's no hocus pocus, there's no mumbo jumbo. There is, I mean, I can explain it to you and understand it, which means I believe it, because there's no, oh, then a miracle happens and just trust us. That's not necessary. The result of this 256-bit hash, where they take your username and password and hash that to get the key for the encryption, that is used with the industrial strength, maximum strength AES 256-bit cipher that we've talked about, which takes 128-bit blocks at a time and turns it into 128 bits of gibberish under the influence of the key. So the whole concept here is that we establish a database of domains that we're logging into and username and passwords for those domains. And this is our personal database. And the beauty of this, and I've been playing with this now for about a week, is that, for example, I did change a couple passwords because I've been a little lazy too. And I thought, okay, now's the time. So I changed those passwords here at home on my system in Firefox, and changed them in the website, and LastPass watched me change them. I said, okay, remember this, and LastPass remembered it. And then the next morning on my iPad, I wanted to log into the site. Well, I didn't write it down. I mean, you can't write these things down. Well, you could, but it would be a pain. Using my iPad, and I don't remember if I was using the bookmarklet for the iPad, which is easy to create, and I have, or LastPass's own iPad tabbed browser, which they have available. But whichever, I opened the site, went to the logon page. LastPass saw, it was the tab browser because it was an automatic process. The bookmarklet, you invoke it to fill in the form. It won't do it for you automatically. When you're using any of these plugins, which are so widely available on virtually any browser that allows a plugin, they've done that. And this is all cross-platform: Windows, Mac, and Linux. All of this stuff. So it automatically saw that I was at the logon page, populated the form, and hit login button for me. So the whole process was automatic. I mean, frankly, I've been spoiled now in the last week because this thing works so well. And my point was that because this exists in the so-called cloud, in the internet that we're all connected to, the change that I made in the logon credentials for that site, whatever it was, I don't remember now, it was stored by LastPass. The plugin resynchronized itself with LastPass corporate, and they're on several continents and several different data centers. They back up themselves locally, and then they back up to using Amazon's S3 service nightly, so that that's all being kept safe. And we'll talk about what happens if they go away in a second. And then the next morning, on a machine I had not used, on a platform I had not used. I was able to log in seamlessly using these new credentials because it was synchronized through the internet. I mean, it's absolutely perfect. Now we've established this fantastic database, different passwords for everything, but we're dependent upon it. We can't function without it because we're no longer using, something simple that we memorized, or we're no longer using something complex, like our one master galactic password that we're using everywhere because we know that's not safe. But now we become utterly dependent upon LastPass. I mean, it holds the login jewels to our entire online existence. So is that safe? I mean, can we depend upon it? Well, we don't have to. They have covered that base too. They have a standalone executable, a standalone gizmo. Trying to think of what it is they call it. Not Sesame. That's their one-time login deal. I've got it written down here somewhere. Maybe. Oh, LastPass Pocket. Called LastPass Pocket. Available for Windows, Mac, and Linux.
I've never used it, but it's that's another feature I think is really important.
And I have used it. What this thing does is it is a standalone personal database decryptor. So you can, using their web interface or using any of these plugins, you can say, I want to dump my database. You can, if you want to be risky, you can dump it using one of these plugins as a CSV, a comma separated value plain text file, meaning that what you will see is all of this data, the domain, the username, and the password that they're holding for you in clear text, in plain ASCII. I say that it's dangerous because that would be like a feast for any malware that happened to be on your machine. I mean, that there in pure readable, simple text file is all the way to access all of the things you've ever access. What's cooler is, but you can do it if you want to, and then, copy it to a CD or do whatever you do with things that are really vulnerable. What's cooler is you can dump it in its native form in that encrypted blob that only you know how to decrypt. And you can do it anytime you want. So I would say, for safety, every few days, or actually anytime you make major changes to this LastPass database, it's as simple as clicking on the little LastPass button on your browser and say, dump. Export is the word they use. You export this entire blob of encrypted data to your drive. Now, what's cool about it is that the LastPass Pocket app, it doesn't install, no setup. It's just a simple, it just runs executable, which is, the kind of exes I love, or executables I love. You are able to give it your username and your LastPass password, which is the way this whole system functions, and then it's able to decrypt your backed up blob and allow you to view it, to see it, to browse it. So in addition to everything else, this is trivial for you to carry with you. You can stick it on a thumb drive, or on a CD, or leave it lying around. It's just a blob of gibberish. It is absolutely invulnerable to attack. It's the same content that they're storing for you. It's no longer synchronized in the cloud, of course, because it's now a standalone file. But what it does is it gives you the security of not needing to depend upon dynamic connectivity to the internet. Now, the plugins do store a local copy of this, so that if you were offline, the plugins in browsers have their own most recent copy. So you're still able to access them locally and look at the data. Now the next thing we need to look at is the vulnerability to somebody impersonating you logging into LastPass. Because notice what we've done now is we've created valuable content. It's now safe with the LastPass folks. It's now backupable. We're able to clone it to create our own local copies. So, and we've got viewers that run on all platforms. So we know that we'll be able, if the worst happens, to manually look up, gee, what is my password for, Amazon.com? And I should mention also that there is a secure password generator as part of LastPass, as part of the plugins. You can customize it a little bit. You can tell it how long you want your passwords to be. You can say, I want uppercase A through Z, lowercase a through Z, the digits. I want to allow or not allow special characters. I want to require a certain number of digits to be in every one of these, which gives you maybe a little more security. And also, of course, you're able to specify the length anywhere from 3 to 100 characters. Well, don't use 100 characters. First of all, many sites won't accept a 100-character password. I would say, and I thought about this for a while, 10.
Yeah, I was going to ask you. This is a great question.
Yeah, I would say 10
is enough. If it's random, it's upper, lower, punctuation, and numbers.
Yes, if you were to use, even without special characters, I'm a little hesitant about special characters because some sites will barf a little bit if you use, funky random, circumflexes and tildes and vertical bars and things. So let's return again to upper and lower case, which gives us 52, the digits, which gives us 62. Well, 62 is not quite 64. It's obviously too short of 64. Well, that happens to be, don't ask me why I know this, 5.94 binary bits of equivalent strength. Not quite 6 bits, 5.94.
It's one of those random things you just have in your mind,
something that you cryptographers know. So if we take 5.94, and I got my calculator in front of me, we multiply that by 10. Well, that was easy. Why did I multiply? Why did I get my calculator? That's 59.4. Oh, I know why I got it. It's for the next operation. 59.4 bits, equivalent bits of binary strength. And so if we raise 2 to the power of 59.4, I didn't do it. 2 to the power.
Do you have a calculator in front of you? Is that what you're doing?
Yeah, of course. It's my beloved HP. Oh, I meant the swap.
Have you tried, completely off purpose, go ahead and keep typing. Have you tried any of the iPad calculators? There's one called 42 that's really good.
That's the one I have.
It's awesome.
I love 42. Yeah. Of course, we know why it's called 42.
We do.
Also.
It's the answer to life, the universe, and everything.
Okay, so here we have a 10-character password using only upper and lower case and the digits with 5.94 binary bits of strength per character gives us 7.6 times 10 to the 17th possibilities.
That's a lot.
7.6 times 10 to the 17th.
I think that's the number of stars in the galaxy or something. That's a large number.
Yes, and this is they're randomly chosen. They're gibberish. I would say no reason to go any stronger. You can if you want, but someday you might find yourself, for whatever reason, needing to type one of these in manually. For example, did I mention that all of this is free?
There is a paid version. I mentioned at the beginning I pay $1 a month, but everything you said so far, except for maybe the database dump.
No, it's the mobile stuff.
The mobile stuff's not free.
The mobile browser stuff is what they charge for. They have said that they're going to reserve the right to put ads somewhere. Some of their stuff is web-based, where you end up using a secure web page, for example, to view your vault. You're able to view it locally also. The browser plugins open it up. In fact, in Firefox, it's Chrome : / and then the path to the file, which they provide. So,
by the way, 10 to the 17th, it's the number of meters in a light year.
No kidding.
I'm just looking up orders of magnitude.
Very cool.
And it is roughly, it's a little less than the number of stars in the galactic arm.
Okay, that ought to do it. Yeah. 7.6 times 10 to the 17th. Good luck guessing that, FBI. Anyway,
I'm sorry. We were talking about the free stuff. What's free? What's paid? And the mobile is the mobile. Yeah.
So the stuff you pay for. So conceivably, they could put some ads somewhere. I haven't run across any yet, and they've said they will be tasteful, little Google text style ads. I mean, these seem to be great people from everything I've seen, and I've got some of the questions that I had answered through some email exchange, and they've been also very responsive. So it's the mobile stuff that you pay for. So the mobile versions of the applets, but all of the browser-based stuff, all of the regular browser, I mean, like phone mobile is what I meant, is free, as is the iPad Touch, the iPad tabbed system is free. Let's see, premium. Oh, they do have. We'll be talking about one-time passwords in a second.
And YubiKey support and all that stuff.
Yes.
But the real reason I pay them $1 a month? Because it's cheap and it supports the further development of the program.
These guys deserve it.
I don't pay them for the additional features. I pay them because they deserve it.
Yes, exactly. So my point was that I have the LastPass BlackBerry app on my BlackBerry. My BlackBerry now contains an encrypted copy of my master database, and if I ever need to log in somewhere where I have nothing with me but my phone, well, first of all, anything I'm logging into is a browser. So any browser that I encountered, I could use a bookmarklet in order to log in.
That's how I do it on the iPad, by the way, and the iPhone. That really works well.
Yeah, and it just works perfectly. It fills in the form for you. It's like, oh, well, off you go.
It's kind of neat.
It's very cool. It's like magic.
It's hard to believe.
It's like, I'm so spoiled now.
Don't tell Steve it's using JavaScript.
Yeah, we'll be talking about that in a minute, actually.
Okay.
So I would have my phone with me. So there I have the ability to authenticate to my phone locally. That is using without any connection. I give my phone my LastPass username, which is my email address, and my LastPass password. That unlocks for in there the copy that my BlackBerry has, and I can look up my username and password for any of the sites in that database and unlock my own private note vault of stuff that that I want to, like, for copying, pasting, or whatever, because they also support this idea of notes. And remember, they do form fill-in. I have had it successfully now populate several different e-commerce sites that I went to with my credit card information. I know LastPass only has an encrypted form, and this decryption happens on the fly in the browser using JavaScript, or where there's a plugin present, encode in the plugin, so it's secure. So because it's conceivable that I might need to manually type the password in, 10 characters, which we've seen is 7.6 times 10 to the 17th possible combinations, that's feasible for me to read off the screen of my iPhone or my BlackBerry and manually type in uppercase A, lowercase z, 0, 2, uppercase Q, lower, and so forth, and be able to log in. So that's covered. However, we want to make sure that so what we've done is we've concentrated a huge amount of value into our LastPass authentication, because authenticating with LastPass now literally unlocks the keys to our kingdom. So how is that made safe? Well, it's made safe through several techniques that we've talked about in the podcast in the past. They support something very much like my own perfect paper passwords. They call it the grid. And using when you log into LastPass and authenticate, you can have them generate for you a random grid, which is A through Z and maybe 0 through 9. I think that's all it is. It's very much, they liken it to Battleship, because so it comes up on the page on your browser, you print it, you snip it out, and you carry it in your wallet. When you activate the grid, then any authentication is challenged by, after you give them your username and password, they challenge you by saying, tell us the characters at B4, C9, Z7, and Q2. And so you got to get out your grid, and like playing Battleship, you type in the character at each of those coordinates.
That's cool.
In order to say this is really me, because as we know, this is another factor of authentication. Now it's something I have in addition to something I know. I know my LastPass password. Now it's also something that I have.
Is that kind of how perfect paper passwords is almost like? No.
Well, perfect. The one
it's not
thing
a matrix.
The one thing that perfect paper passwords does is it never reuses any of the strings.
It's the one-time thing, yeah.
Yes, it's one time. Now, the grid could potentially, I mean, in your farthest worry would be that something is watching you log on using the grid and is learning your grid. So the only thing I would, and I don't know, I have meant to ask, but I forgot to ask, if they have any, like you need to update your grid. They absolutely allow you to kill your grid and make a new one. So, for example, if you lost it, or if you left it somewhere, you'd want to kill that one and make yourself a new one, which would be completely re-randomized and brand new, and the other one would die and no longer be useful. And that's true of bookmarklets, by the way, also. You're able to deliberately kill any bookmarklets that you might have left on a different browser somewhere, or you might have temporarily installed somewhere. If you change your LastPass password...
That happens anyway, because I've done that.
Yes.
And none of my bookmarklets work anymore.
Yes. If you change your LastPass password, then, and you could tell, Leo, I really learned this thing.
Yeah, because I mean, I've been using this for a year, and you found stuff I hadn't even discovered yet. So yeah.
So if you change your LastPass password, that obsoletes your bookmarks, but you can also explicitly do that just for security purposes, although you will then have to recreate them manually. But that's easy because you're just able to drag and drop them from the page onto the shortcuts bar. So you can, so I would say if you're a grid user and you're a heavy grid user, just obsolete the grid yourself. I don't know whether these guys do or not. Obsolete the grid yourself, every few months, so that, I mean, it's very far-fetched that anything is memorizing your grid behind your back, but that's the only possible problem that I could see where perfect paper passwords is a little bit better. So the other thing they support is a very cool software one-time password generator. Oh, and you can even make one-time passwords. That is, using their web interface, you're able to say, generate for me some one-time passwords. And you can click on it a few times. I made up 10, and they're long mothers. They're like, whoa, okay, I'm going to print this out or write this down very carefully. And you can use those if you know in advance that you're going to be somewhere where you want to make sure no one can ever log in again. And so they just like emit some, every time you ask for one, they'll generate another one, and you could print them out and carry them with you, and then they'll just cross them off as you use them. So, and they're good until you kill them, and you're able to kill them at any time, or you use them exactly one time. So they have a built-in one-time password generating facility there. They also have sort of the equivalent of a software YubiKey. They do support our very favorite Stina Evansfard Yubico's YubiKey. And I tried it out, works great. You just go there in their configuration dialog on their website. They have got a tab, a YubiKey tab. You go there. It's got room for, I think, maybe 8 or maybe 10 different YubiKeys, so you're not just stuck with just one.
Well, that's good, because I worry about losing any kind of a dongle. Right.
And so you're able, so what I did was I plugged it in, set the cursor there, touched the YubiKey. It saw, it got my YubiKey string, and that's all I had to give it. Because remember, the YubiKey has an ID as part of it, and then the one-time password portion. And so you look up the YubiKey. They checked with Yubico Central and said, yep, we know about that YubiKey, and now we're ready to go. So you're able to have multiple YubiKeys, and so what that would do is that's used anytime you need to authenticate with LastPass, and you can choose the security level, like with multiple checkboxes of like, I want to be able to generate passwords with LastPass, that is, have LastPass do all of its things and only authenticate once. I want to require authentication every time. I want to authenticate after so many minutes. So there's various ways you configure lockouts and the need to re-authenticate. They do have one of their premium features, which is the $1 a month thing that Leo was talking about. They have something called Sesame, which, as in Open Sesame, is kind of cute. It's an app, again, cross-platform, Windows, Mac, and Linux, which it's like a software one-time password. So it does the same thing that the cool little YubiKey does.
That's what I want.
Yes.
Because then I can't lose it.
Then exactly.
Yeah.
So you download it from them. You stick it on the USB.
Any USB key.
Any USB, as many as you want.
I like that.
You need to authenticate to it, but when you do, it'll automatically log you in on it'll launch your browser, log you in, and authenticate you all in one process.
Yeah, I'm getting it right now.
It is very cool. And they do have a support for IE Anywhere, which is the sort of the mobile transportable version of IE, which is useful because, of course, IE is pretty much everywhere. And the last thing is import. They do allow you to import from pretty much everything I've ever seen. And I'm going to run through it just once. So if you're currently somewhere else, and I've sold you, as I have sold myself, on this thing being like the answer, you can import from Firefox's Password Manager. I had been using Firefox's Password Manager. Instantly, LastPass knew about everything that Firefox knew, which was extremely cool for me. Also from 1Password, from Clippers, from something called Darn Passwords, from eWallet, from Fireform, from HP Password Safe, from KeyPass, obviously from LastPass. It's able to import its own file, by the way, from MSI Password Keeper, from My Password Safe, from PassPack, from Password Agent, Password Corral, Password Dragon, Password Keeper, Password Safe, Passwords Max, from Pins Password Manager, from RoboForm, from Splash ID, from Sticky Password, from SXIPPER, Zipper, I guess, from Turbo Passwords, and from a generic CSV file. So pretty much everybody there is, you can instantly suck your database in using their import feature of the plugin, and you're moved over to them.
It's amazing.
They just did it. Oh, and form filling is a very cool tool. You can give it multiple credit cards.
I do that, yeah.
You can tell it all about yourself.
These are features that many browsers have, and the point is this is a more secure way to do that, and it turns off those browser features, by the way, if you ask it to.
And cross-platform. I mean,
right.
It's nice that a browser has it, but then you go to a browser you've never been to. I mean, even just it happened to me in this last week. I set up a new system, and I said, "Oh, wait a minute, I have LastPass." So I added the plugin. Instantly, that new system knew everything about my world.
You know what you've done, Steve, is I've been using LastPass in the kind of a fundamental, basic way all this time, very happily. I've used the bookmarks, you know, and the various features, but now I'm going to go back and turn on some of these advanced features. I love this idea of being able to put a USB key with this application on. I'm going to start doing that because I like multi-factor. You've taught me to love multi-factor authentication. I'm going to start turning that on. Well, that's a nice thing.
It is the case that we are now storing all of our eggs in one basket.
Yep.
So you want it to be a safe basket. You want it to be a basket you can back up and a basket that nobody else can get your eggs out of. And they really have nailed it. I mean, I don't see a single problem with this. The crypto is clear and simple. And you know, they've arranged so that they're never going to be in a position of anyone being able to like steal their stuff. Notice also
because they don't have it.
Right. Notice that no subpoena that they're served can force them to divulge your information. They don't have anything.
They don't know.
They have only the result of the best encryption that our world. The AES 256, the best, strongest encryption that we know how to produce, they only have the product of that. They have the encrypted blob, and they have no key to it. They never get the key. It all
That's
stays
very
local.
clever that they did it that way. I think that's incredibly clever.
Yeah, it's correct. They did it right. From start to finish, and multi-platform, so they're not biased towards Windows and against Linux folks. Windows, Mac, and Linux across the board for all of this. It's done.
Steve.
LastPass's network breach. Of course, the press went crazy, and my Twitter feed was literally useless yesterday because, I mean, I thank everyone for making sure that I knew.
Steve, did you know? Had you heard? Did you know? There was a problem. Did you hear that?
Yeah. And in fact, what Joe said to PC World was they dramatically underestimated the media's reaction to his blog posting and the email they sent out. Turns out that LastPass has grown so popular and they had so many people to notify that it became very difficult to get the mail out. And so they used an Amazon service, and they're going to use Amazon's scalability moving forward.
Well, let's give some practical information here. What do you recommend? For people to do who are LastPass subscribers, should they change their email?
No. Okay. Okay. So the point is, only by being a target of an attack are you in danger. So you want to do two things. You absolutely need to change your LastPass master password, because if this data got out, if you were targeted, if you had a weak password, and if they could figure out how many iterations to use, then they would be able to confirm the password that you were using on LastPass and have your email address, therefore being able to impersonate you to LastPass and get all of your LastPass login authentication. So you absolutely want to change your master LastPass password.
Right, I did that. Of course, I promptly forgot what I changed it to, but that's another matter.
And many people, it happens to many people.
It's really easy to do, especially because you're using a long. The real challenge is you want to come out with a really nice, random, long password, but you also want to be able to kind of recreate it. And I use poetry, the first letters of lines of poetry, but I misremembered the poem apparently. So now I have very difficult, but that's okay. Others have had this problem too, I'm sure.
For what it's worth, many people had the problem. There are instructions at LastPass for reverting to your previous forgotten password if that happens.
Is that a safe thing to do? I'm surprised he even offers that, to be honest.
I am too, but I think unfortunately, these are all the problems that we have. You know, last week when I demonstrated clicking the QR code, someone in the chat room said, "How is that better than the browser memorizing my password?" And it's like, oh my Lord, you know, what we're doing is we're shoring up an existing horribly broken system with, you know, one attempted solution on top of another. And so, you know, this whole issue, you know, we've got to the point now where we have to use different passwords for every site, so no one can remember those. So we have to use a password manager, but we're also using different computers and different devices. So we need synchronization. So that means that synchronized database needs to go into the cloud. And now, you know,
that's the problem, by the way. If you didn't need synchronization, you could just have an encrypted file on your desktop. If you didn't care if anybody else saw it, you wouldn't need to do that. But synchronization is what we want, and that's the problem.
Yes, and how many times have we been saved by LastPass keeping things synchronized?
Right.
You know, because we do change a password over on some device on some site, and it's almost a miracle. I mean, it's wonderful that then you later go to a different computer and it knows how to log you on there.
You know, I'm kind of lucky because I have two LastPass accounts. We have an enterprise account, and I have my personal account. And I had merged my personal account into the enterprise account, which you can do. You can, for ease of use, if you have an enterprise account, you can have both your LastPass accounts. And I had done that. So I changed the enterprise password, saved that, thank goodness, for my enterprise account. And everything's in there. So the fact that I can't get into my personal account is not really a problem anymore. Let me ask this.
So my answer is, for your LastPass master password, it needs to be something big and random, and you have to write it down.
Put it somewhere.
And I don't mean it literally. You have to record it.
Yeah.
So you know, like do cut and copy and paste and put it somewhere else. Put it somewhere, you know, maybe print it out or maybe put it in some other place which you feel is secure.
The problem is, because of synchronization, you need it on all the other devices too. So you have the same problem.
Or maybe put it in your wallet, but also make some change to it. Don't have it be the exact one. You know, leave out, you know, change a digit.
That's a good idea.
Yep, and when it doesn't work, then you'll remember, that's right, the last digit is actually,
Is there a better solution? Is this mean that we shouldn't be using LastPass?
No, I don't think anybody okay, so in some subsequent postings, Joe acknowledged that some lessons were learned. And so, for example, one of the things they're going to do is they're going to rely more heavily on Amazon server scaling so that they're able to scale their performance to better deal with this kind of surge in everybody needing to do something massively computational burdensome at once. And I got the sense that they're going to do some additional network segmenting. Ultimately, that's really what you want. You know, we've talked about this like in the Sony hack, where one of the horrible things about that was that apparently everything was available on a single network. So where your network is about security, as is the case with LastPass, rather than about convenience, which was the case with a bunch of, you know, entertainment people in Hollywood at Sony Pictures, there it really makes sense to put, you know, to separate networks. It means that it's less convenient, but wow, you know, ultimately it's probably what you have to do. When the reality is everybody makes a mistake, as you know, as that cartoon at the top of this show said, you know, despite your firewalls and your antivirus and your everything, you still got Dave, who is going to click on the link in the email from his mother and infect his computer, and he's in a trusted network in a company that's all about trust. So my point is, to answer your question, I'm not leaving. I'm staying with them. I mean, I've always thought it was sort of odd that oftentimes employees are fired when they make a mistake that taught them a lesson, because you've just lost somebody who knows more than they knew before, and you're going to replace them with somebody who hasn't learned that lesson.
Yeah.
And hasn't been chastised. So I've never understood that. I mean, malice is one thing, goodbye, but a mistake, that happens. So, all of their technology is bulletproof. For example, there is nothing I can think of that they could have done more, obviously, except not have this happen. But given that it's happened, the environment that it has happened in is as secure as anything I could imagine. And look at how diminishingly small the risk even now is. It is incredibly difficult for someone to obtain one person's password, maybe, which they've probably changed and hopefully didn't use anywhere else, because the whole point of LastPass is you don't have to use the same password everywhere. And LastPass gives you auditing facilities to look at all the passwords you're using that it's storing for you and verify that they're unique. So, I mean, it's not, maybe they were trying for more and this is all they got and they're not happy. I mean, maybe nothing's going to even be done with this. So again, from a practical standpoint, I can't think of anything more they could have done. Users should change the LastPass password and also change other sites' passwords if you were using them also with LastPass.
Never do that again.
Right.
You should also turn on two-factor. I mean, I didn't feel the need to change my master password. I did, but I feel like
two-factor doesn't help you here.
It doesn't help you.
You notice I didn't mention it at all.
Didn't. Okay, tell me about that.
Two-factor is orthogonal to this. This is all separate. Two-factor comes in after you've authenticated yourself. So it would prevent a bad guy from logging in with your old LastPass password if you did not change it. So that part is useful, but it does not. But the two-factor still allows them to do this attack and determine what your LastPass password was. So if you did have second factor, you're safe from them logging in as you, but you're not safe if you reuse that password anywhere else.
But you shouldn't have been reusing it.
I hope you found this video useful. If you did, please hit that like button and subscribe if you're new to my channel. Till next time, I've been Carl Rides, and thanks for watching.